substitution is. Here you can see that in this reaction we have two substituents, F and X, right, where X denotes substituent indicated in the option below. So what will be the X? We have to check the order of reaction in terms of different substitution instead of X, right? So here we have fixed F fluoride, which is a strong electron withdrawing group, right? When we have electron withdrawing group here, and this will act as a nucleophile, right? This is a nucleophile. So this is an example of nucleophilic substitution reaction here, and in this case, when the nucleophilic substitution reaction occur and electron withdrawing group is there, that time it will act as a ortho and para directing in case of nucleophilic substitution reaction, right? So here if we will consider NO2, here what will happen? It is a electron withdrawing group, right? So the electron density on this ipso position will be so ortho position will be electrophilic, right? And similarly, if we will rotate if we will draw the different resonance structure, we will find that para position is also electrophilic, right? Okay, so para and ortho positions are electrophilic. So substitution reaction will occur at para position, major product. Because of hindrance point of view, it will not create hindrance. The para substituted product will be the major product. At ortho position, it will give a hindrance. That's why para position will be the stable one. So as you can see here, para substituted product is there. And this reaction will also occur via benzene intermediate. I called you earlier also, benzene intermediate formation will take place. How it will take place? The proton abstraction will take place first from the starting material. Minus H plus will take place to give the this way benzene, correct? Now this benzene will undergo a reaction to form a para substituted major product. Para substituted major product. Okay, so in case of nitro, it will be a major product. Now talking about the cyano. Cyano group is less electron withdrawing compared to the nitro one. That's why the rate of reaction for nitro will be higher than the cyano, because of strong electronegativity of this NO2 group. So you can see the option 1 and 2 shows the NO2 highest electron withdrawing capability here. So these two options are incorrect, right? Now talking about the another group, which is CO2Me. Again, this is a electron withdrawing group, correct? This O is not there. Okay, so this is a electron withdrawing group. So this will again act as a para directing group, and it will give this as a product. So the option number A is the correct one, because methyl group is not a electron withdrawing group. It is a electron donating, it shows the electron donating ability, which will give the meta product as a major product. So because of this option number B is incorrect. The option number 1 is a correct one. According to the electron withdrawing capability, the option number 1 is correct. Nitro group is the highest electron withdrawing group, and then the cyano, and then CO2Me, sorry, COMe, right? So the option number 1 is correct here. Now moving to the next question. Question number 7. The product of the following reaction is. Here we have two starting materials, two substrates, and we have to find out the product. So here you can see we have given 4 different options, which will be the product. So you can see this is a Friedel-Crafts alkylation reaction, right? Friedel-Crafts alkylation reaction. So in this case, nucleophilic substitution reaction will take place. Why the nucleophilic? Here this negative charge, sorry, So again here we have here a fluorine atom, which is a strong, which is highest electronegativity, strong electron pull ability, right? So it is because of the highest electronegativity, it will pull the electron, and it will give the -I effect, right? -I effect. And because of this ability, it will be a meta directing, sorry, ortho and para directing. Why it's ortho and para directing? All of you know about alkylation and acylation, right? Here it is a alkylation, not acylation. In case of acylation, it is a meta directing, but here this is a case of alkylation, so it will be a ortho and para directing with respect to fluoride ion, right? So because it is a donating group, not a withdrawing group, and if we have acylation, that time it will act as a withdrawing group, right? So in case of fluoride, it will give either a para product or a either a para position product or a ortho product. So in these 4 options, all of you can see here, option number A has a meta product, right, which is not correct, and option number B is para. So this can be a possibility, this one, right? And talking about C, again this is a meta product, which is again incorrect option. So option B and D are can be the possibility of the product. Now talking about the option D and B, which one is the major one? So in these 4 options, you can simply neglect the option A and D, because in these 2 cases, in this not option A and C, because in these 2 cases A and C are the product, which is not possible here, right? So these 2 options are already neglected. Now talking about the option 2 and 4, which will be the major product. So in case of the para directing, this phenyl group is a ring, phenyl ring, which is a huge ring if we will draw like this one, right? And it will create hindrance when it is on ortho position. While talking about the para position, the hindrance will be minimized, right? At para position, the hindrance will be minimized. So that's why the B will be the major product and D will be the minor one. So the option number 2 is the correct one. Major product B and the minor product is D. Okay. Now next is question number 8. Identify the reagents of the following transformation. So here my screen is visible to all of you. Is it? Okay. I hope it is visible. Now the question number 8 is identify the reagent of the following transformation. So as you can see here, we have started with benzene ring, right? In benzene ring, what we will do to introduce this COCH3 group. So as I have discussed about the Friedel-Crafts alkylation and acylation. So here you can see Friedel-Crafts acylation is taking place. This is a acyl group, right? So the first reagent will be the Friedel-Crafts acylation reagent. So in these options you can see in Friedel-Crafts alkylation and acylation, in both cases AlCl3 is used, right? AlCl3 is used in all the three cases. So this option D is incorrect one. First of all, you have to find out the incorrect option. So in these three options, first step is Friedel-Crafts acylation. Friedel-Crafts acylation, as you can see in all the three options, right? Now in what will be the reagent B? So after this acylation, chlorination is taking place, right? Chlorination, not a chlorination is same as a bromination. We have discussed earlier, right? And we have discussed that when electron withdrawing group is there, this is the electron withdrawing group. All of you agree with this one? This is the electron withdrawing group, correct? So it will be a meta directing group. So we have discussed in electrophilic substitution reaction that electron withdrawing group behave as a meta directing group, and when the electron donating group is there, ortho and para products are the major product. So because this is a electron withdrawing group, the meta substitution will be the major product, and this is a chlorination reaction. So in bromination reaction the reagent was Br2. So in chlorination reaction the reagent will be Cl2. All of you got this one, right? So in all the three cases Cl2 is there. So still we have to find out the reagent C, correct option, right? So in this reagent C, as all of you can see, this acyl group is nothing but this one, correct? So to make this two, this what we have to do? Reduction of carbonyl group, right? So reduction will takes place. Here you can see reduction takes place in option 1, 2 and 4. So 4th is already removed because of this acylation reaction. So that's why the option 1 and 2 are there, and in option 1 and 2 the correct option is option B. Why option B? Sorry, not option B, option A. Why option A? Because in chlorination reaction FeCl3 act as a catalyst. In bromination it is not required, but in chlorination reaction the reagent Cl2 FeCl3 is required. So you can check the video, and the correct option is option A. The last one is a reduction, okay? Now the 9th question is, this is the last question here. For the sequence below, identify X, Y and Z. So this question is also discussed with Professor Chakrapani sir on YouTube videos. So here in X, what will be the here the reagent is given on arrow, and you have to find out the substitution X. So as you can see here, HNO3 and H2SO4 will give the nitro substitution, right? It will clearly give the nitro substitution. So because here we have electron withdrawing group. So the nitro substitution will be para to the F group, right? Para to the F group. So here we have nitro group as a X. So option D is ruled out here because of nitro group, right? So X is a nitro group. HNO3 and H2SO4 will give the nitro group. Now talking about the Y reagent, what is Y here? We can, after getting this nitro group, to make it NH2, it will undergo reduction, right? It will undergo reduction to make this one. So reduction can be possible in which condition? H2PDC or lithium hydride, right? So H2PDC is a reduction condition to make nitro to aniline. So option A or option B could be the correct answer. Sorry, not option C, right? Sorry for the confusion. I will remove here. Okay. So we are finding about Y reagent, right? And Y is a reducing agent here because we are converting NO2 to NH2. So option A, Y is NaNO2, which is incorrect. It is not a reducing agent. That's why option A is incorrect. And talking about the option B, here H2PDC is there, which is a reducing agent. So it can be a possible answer, right? And now talking about the Z reagent, what is Z reagent? So in case of this one, NaNO2 will be giving a cyano group as a product. You can see the slides of YouTube videos where sir have explained in detail. So NaNO2 will give the cyano group on the from NH2 to cyano group conversion in presence of NaNO2 is possible. Okay, so this is the reagent Z, and now the last one is HNME2, which will give the NME substitution over here via benzene intermediate formation. So the correct option which is here is option B. Okay, which is option B. So here the question is over. Thank you for your kind attention. Now in summary, I would like to give a short summary here. So today we have done the week 2 NPTEL TA class where we have discussed about the yes. Sorry. Yes, I will. More question you want? Wonderful. Okay. I will give a brief summary. That time you can understand that. Okay. So I am just going to give a summary. So in that it will get covered. Okay. So in question number 1, we have in this TA class we have discussed about the electrophilic substitution reaction and nucleophilic substitution reaction. So in electrophilic substitution reaction, the electron donating groups are the groups are the ortho and para directing in case of electrophilic substitution reaction. Remember this word. Okay, so in electron donating groups are ortho and para directing, and electron withdrawing group are meta directing in case of electrophilic substitution reaction. So here we are talking about the bromination, and bromination is an example of electrophilic substitution reaction because bromine is act as a electrophile. So here we have discussed this question as nitrogen lone pair will push electron here and it will form an intermediate like this. We have discussed here, as you can see. So and this negatively charged carbon atom, nucleophile will act on bromine and this will get knocked out as a manganese bromine ion to get the product, this one D, to get the intermediate, this cationic intermediate. So the most stable cationic intermediate is D because of the lone pair push here, and this is the most stable structure because of resonance, right? So the correct option is option D. I have written here mechanism as you can see here. Okay, now we have discussed the question number 2, where we have find out the major product. So here again we have discussed the substitution reaction, where this reaction, as I discussed here, this reaction is goes via, because this is donating group. I have discussed here OCH3 is a electron donating group. I have already told about the electrophilic substitution reaction and nucleophilic substitution reaction. So this is the case of electrophilic substitution reaction again, like a previous one, and this OCH3 is a electron donating group. So the para and the ortho substituted product are the major product. So we have checked the 4 options, where in option B we observe that this is a meta directing group, which is meta 2 OCH group, and this is not the activating group. So this is the incorrect option. And we have observed that option C has a para directing para 2 OCH3. That's why this could be the possible answer. Now talking about the D, again this is the meta 2 OCH3 group, which is incorrect one. And in option A we observe that this is a ortho to this OCH3 group, right? So in option A and C could be the possible answer between option A and C, but the option C is the major product because of the para directing group, and it creates less hindrance. Here you can see the hindrance is very high. If you will write openly CH3, so this is the hindrance will be there, right? Because of hindrance it become less stable, and the major product will be the option C. C will be the major product, A will be the minor product, and B and D are ruled out. Okay. Now talking about the question number 3, here in this reaction we have observed that this reaction is going via a stable intermediate formation, which is a benzene intermediate, right? Here I have written benzene intermediate. So what will happen in this case? Proton abstraction will take place, followed by knockout of chlorine group Cl minus. It will give a triple bond here, benzene intermediate, and this benzene intermediate will undergo a substitution reaction, nucleophilic substitution reaction, to get the meta directing product. So I have discussed earlier, in electrophilic substitution reaction case, electron donating group will direct the group on ortho and para position, but in case of nucleophilic substitution reaction, the meta position with respect to electron donating group will be the stable substitution product. Okay, so here we have OMe group, which is a electron donating group, and NH2 is our nucleophile. So this is a nucleophilic substitution reaction. So meta position will be the most stable position in this case. So the product, meta substituted product, will be the major product here. Okay, so in case of A, option A, it was the ortho, so it was not the correct option. And in case of C, which is completely ruled out because there is no substitution of NH2 is there. And talking about D, it is para directing, which is also incorrect, right? So that's why the option B is the correct option, which is meta directing product. Now the next question is question number 4. Here the correct order of rate of bromination is. So I have discussed in question number 1, bromination reaction is electrophilic substitution reaction example, right? It is an example of electrophilic substitution reaction. So in case of benzene, now here we have compared 4 different options. In benzene there is no substitution, right? And in case of this methyl substituted benzene, one methyl group is there, right? It is a toluene, right? This is toluene, and in this option C there are 2 methyl substitution present on benzene ring, and in D again the 2 methyl group is present on benzene ring. Now talking about the rate of reaction, we have already discussed that the electron donating substitution on benzene ring will enhance the rate of electrophilic substitution reaction, right? Electrophilic substitution reaction rate will be higher with the substitution, electron donating substitution on benzene ring. So here all of you can see all the substitution present on benzene ring are methyl. There is no electron withdrawing group is present, right? All are electron donating groups. So that's why the rate of these substituted benzene ring will be the higher compared to the rate of benzene ring in case of electrophilic substitution reaction. So that's why benzene ring will be the least reacting group here. So the rate of the reaction for benzene will be the least one. So as you can see in all the 4 options, A is the last option in terms of rate of the bromination reaction. Okay. Now we are going to compare in between these 3. So in case of B, you can see only one substitution is there, and I have discussed in question number 1 that electron donating group will be a para and ortho directing group. So here the substitution can be occur at ortho position and para position, right? So both the ortho and para position are possible in this case. So the rate will be higher compared to the benzene ring, right? Because in NMR this ortho position value is coming around something 7.0 around, right? If here OMe group will be there, then it will become in 6 point, right? In case of methyl group it is around 7, and in case of benzene it is around 2.27. so the rate will be higher compared to the benzene ring for this methyl substituted benzene ring, right? Now talking about the option C, here you can see 2 methyl group is there. I have given number 2 methyl, 1 for this methyl group and 2 to another methyl group. Now the substitution occur in terms of first methyl group, so it will, this position will be the ortho position and this will be the para in terms of this methyl group, right? Now talking about this second methyl group, so this position is meta to this methyl number 2, and this position is again meta to methyl number 2, right? So that's why these two have a activating as well as deactivating group because of the adjacent methyl group, right? Now talking about the D, here we have again given a different number to two different methyl group. The number 1 is given to this methyl group and number 2 is this one, right? Now the ortho position of this methyl group is also ortho to this methyl, and para to this methyl is also ortho to this methyl, and para with this one is ortho to this one. So in all the possibility, in both the methyl group will act as a activating group because both the group the substitution group is ortho to both the methyl group. So both the methyl group will act as a activating group and the rate will become highest in case of D. It will enhance the rate of reaction. So the D will show the highest rate of reaction in case of the bromination. So option A is the correct option, where D is the highest one and then B and C, because of deactivating group of the deactivating effect of second methyl group. Option C is less show the less rate of reaction compared to option B. So the correct option is option A. Okay. Now we have the question number 5 is here. In question number 5 we have discussed the major product formation here, and here we observe that 3 different substituents present on benzene ring. So the one is nitro group, which is electron withdrawing group, and amine group, which is electron donating, and CF3, which is electron withdrawing again, right? And we have discussed here again, this is the example of bromination reaction. In the bromination reaction is the example of electrophilic substitution reaction. I have repeated n number of times this term. Electrophilic substitution reaction is an example of bromination reaction is an example of electrophilic substitution reaction. Okay. So in electrophilic substitution reaction, in terms of electron withdrawing group, meta product will be the major product, and in case of electron withdrawing group effect, ortho and para will be the major product. Right? All of you are clear till here? Now in this case, as you can see, this position which I have circled here, it is ortho to this electron donating group, which is a major product possibility in case of electron withdrawing group, right? This is the ortho position. Now talking about the electron withdrawing group, where in case of electron withdrawing group, meta will be the major product. Now you can see this circled carbon, highlighted carbon is meta to this group, right? And it is meta to this CF3 group also. So again, this carbon substitution will be the most stable substitution here, because of ortho para directing in terms of electron withdrawing group, and electron in terms of electron withdrawing group, it is a meta substituted product. Okay. So here you can see option B is the correct option because of substitution at this carbon atom, which is the most stable product. Okay. Now in question number 6, the question was the order of reactivity in the following series of compound towards nucleophilic aromatic substitution is. Here X denotes the different substituents indicated in the option below, right? So here we are considering X as a electron withdrawing group. So I have discussed that in nucleophilic substitution reaction case, electron withdrawing group will always be a para directing group, right? So here you can see the product is para directing, para to this group, right? Para to this group. So all of you know that then X could be the electron withdrawing group because of this product, right? Now you can check all the option where methyl is written in last, and in some cases it is first, and in the option number 2 it is on third. So all of you know that electron withdrawing effect is should be there to make to get the para position product. Now methyl is electron showing the electron donating effect, right? So it cannot be the first priority. The rate of reaction with methyl at para to get the para substituted product will be the least one. So this is not the correct one. Now talking about the option 2, again it is not the correct one because methyl is there before COMe, okay, before acyl group, right? So that's why these two options are incorrect. Now talking about the option first and third, you can see electron withdrawing ability. So first, the most electronegative group is Na2 compared to Cn, then COMe acyl group. So because of this order, the option number 1 is correct option. More the electron withdrawing ability, more will be the major will be the product, and highest will be the rate of reaction. That's why option A is correct one. So reactivity will goes via this sequence. The rate of reaction will be highest for NO2 substitution compared to Cn, followed by COMe, and least one is methyl one. Then in question number 7, the product of the following reaction are. So here we have discussed that Friedel-Crafts alkylation. So here we have discussed that Friedel-Crafts alkylation will be nucleophilic substitution reaction example. So nucleophilic substitution reaction in case of electron withdrawing group will be para directing. I have discussed earlier. So para directing. Here in option A you can see it is meta directing. This group is meta directing to F. That's why it is not the correct option. Option number C is also ruled out. And talking about option B and D, now ortho and para directing groups are there, but in case of D there will be a hindrance. I already told you steric hindrance will play a role after after choosing ortho and para position, steric hindrance will be the next factor. So here in case of B, there is no steric hindrance. That's why product B will be the major product and product D will be the minor one. So in option number B, the major product is B and minor product is D. So option B is the correct one. Option number 2 is the correct option. Now in question number 8, we have discussed the different reagent which can be possible for the following transformations. So the question was identify the reagent for the following transformation. So in case of A, in first case A, what is A? So here we can see that acyl group substitution is taking place. So this is the example of this reaction is known as a Friedel-Crafts acylation reaction, right? Friedel-Crafts acylation reaction. So here for Friedel-Crafts acylation reaction, all of you know that AlCl3 is used, right, along with acyl group. So this is the combination for reagent A, because in Friedel-Crafts acylation reaction AlCl3 is used. So option D is already ruled out. Now the option the reagent B could be the chlorination reaction, right? Chlorination reaction is same as a bromination reaction. So because this is electron withdrawing group COCH3, it will be meta directing, right? Meta directing group. So this is meta to this COCH3 and okay, meta to this group, and this is a chlorination reaction. So again you can see that chlorination reaction condition is there, FeCl3, and at last they have reduced this carbonyl group to make it alkyl group. So the last step is reduction reaction. So that's why the reduction is taking place in this reaction. Option A is the correct option. Okay. Now question number 9. In question number 9, for the sequence below, identify X, Y and Z. So here X is a substituent present on the ring, right? And I told you again earlier, when F is there, it is a para directing group, right? So para directing group for nucleophilic substitution reaction, right? So here substitution reaction will take place here, and NO2 will comes at para position, right? At para position. So these option D is ruled out here, and these three could be the possible answer. Now to find out the reagent Y, all of you know that from NO2 to NH2 reduction is taking place, right? And which is the reduction condition? So all of you know that H2PDC is the reducing condition and not NaNO2, right? NaNO2 is ruled out. So option first is again incorrect one, and option C is also incorrect. Lithium hydride is there, which is not a correct reducing agent here. So H2PDC could be the reducing agent. Now talking about the Z reagent, where the NH2 is getting converted to cyano group. So here NaNO2 is the correct reagent. So the option number B is the correct option. Okay. So option number B is the correct option. And in last step, again the benzyne intermediate formation is taking place, followed by addition of nucleophilic addition of NME2 group to give the para directing product. Okay. So I hope all of you are clear till here about the electrophilic substitution reaction and nucleophilic substitution reaction, right? If any question, any doubt is there, you can ask me now. Thank you for your attention.